Oxidation reduction. Don't overthink this. If you take away hydrogens, you're oxidizing it. If you're adding more bonds to oxygen, you're oxidizing it. So if you have a carbon right here that now it started out with one sigma bond to oxygen, now it has a sigma and a pi, that carbon was oxidized. It now has more bonds to oxygen. If it loses a bond to oxygen, it gets reduced. Hydrides, you've learned about H minus, right? H minus hydrides are a way to reduce, right, carbons because they add H. They take away bonds to oxygen. Those are hydrides, the reducing agents. Right? You react to those with carbonyls. You turn a ketone into a secondary alcohol, right? So it got reduced. It lost bonds to oxygen. So what we're going to talk about in the second part here is how do I take an alcohol and oxidize it? You've learned ways to take a ketone and reduce it, right, with hydrides. Now, what are the ways to take an alcohol and oxidize it, whether to a ketone aldehyde or all the way to a carboxylic acid? So the most basic way, and I'm never going to ask you to calculate oxidation states, just look at it. Be like, it's bonded to oxygen. I don't know, right? Anytime you see chromium, just think, oh gosh, chromium. Or sometimes they'll say Jones reagent. It's just a fancy, I guess, good for you, Jones is your reagent. CaMnO4, any of these manganese or chromium, it's going to oxidize. It's going to be oxidizing like really reactive oxidation. It's going to keep on oxidizing until it can't anymore. So if it's a primary alcohol, there's two hydrogens on that carbon attached to that oxygen. It's going to get rid of all those. It's going to go to an aldehyde first, and then it's going to keep reacting to a carboxylic acid. Right? It's going to keep reacting. If it's a secondary alcohol, it can only take it to a ketone. If it's a tertiary alcohol, it can't do anything at all. Right? It can't do anything at all. So you really got to look for, right? The key is looking, right? How many hydrogens are attached to the carbon with the OH ion? Okay, so oxidation mechanism. Something I do want you to be able to do. This is what I want you to be able to do. You're presented with this chromium reagent. You should look at this chromium and think, that chromium is electrophilic. Look how many bonds of oxygen it has. It looks like, it's almost like a carbonyl, right? So what's going to happen, if you're an H+, first step, you're going to protonate that, right? So let's just draw that out. We're going to protonate that. We get this. This chromium is super, super electrophilic. The alcohol oxygen, the lone pairs there, are going to react. You're going to break that pi bond. They're going to do that addition step. This was a protonation step. You're going to get to something that looks like this. Right? Okay. What we're going to do now is we're going to do a proton transfer. And you don't need to draw arrows for this. Right? Proton transfer. Essentially what I'm going to do is this H is going to go to one of these oxygen, one of these OHs. Now, it doesn't matter which one. I drew it to go into one of them. Now, why did we do that? That made this OH into water, a really good leaving group, right? Right? Into a really good leaving group. The next step, what I would do, maybe a little different than what they would do. So I wouldn't do this. What I would do, let's see. Yes. Let's do that. That's fine. We can leave it this way. Deprotonation, elimination, kick out, right? So what happened here? Another water came. You regenerated H+, because this was a catalyst. You formed a pi bond, so you did a lot of things in one step here. A deprotonation, and an elimination with loss of water. So make this thing called a chromate ester. Right? Make this thing called a chromate ester. All right, the last step is going to be, right, essentially restarting what you did before. Right? We regenerated H+, so now we're going to protonate this. So the whole rigmarole was just to get the alcohol on the chromium, right? Essentially what you did was you replaced an OH with your OR group, your alcohol group. Right, that's what you did. Acid's going to come in again. We're going to protonate. We're going to protonate again. Now this time, right, because we're doing oxidations, you got to remember, what are we trying to do? We're trying to get rid of the hydrogens attached to the oxygen. The hydrogens attached to the carbon attached to the oxygen. So this is at E2 now. Now you're going to do an E2. Oxygen, or water, which you just created, takes the hydrogen from the carbon, bond to the oxygen. You form that pi bond. Those two electrons go to the chromium. See how you just turned it into an aldehyde? You took away one of the H's that was originally on that alcohol. I want you to be able to do this whole step. I expect that you'll be able to do this whole step. All these steps and understand how to do it. What's going on in each step. All right? Protonation, addition. Proton transfer. Deprotonation, elimination. Protonation again. E2 elimination. Get to that first oxidation state. That first primary alcohol is turned into an aldehyde. So that's all good if, so if we had hydrogens on the carbon attached to the chromium, we could take the H off. We could make an aldehyde or a ketone, right? But what if there are no hydrogens? Can we do an E2? Well, no. If there's no hydrogens there, you can't do anything. That's why tertiary alcohols don't get oxidized, because there's no hydrogens to remove. Right? There has to be hydrogens on the carbon attached to the alcohol. If they're not there, it won't work. All right. I just showed you chromium, super reactive. I showed you a little bit of the mechanism, that first step, that protonation, addition, all those kind of steps. What if we want to stop at an aldehyde? What if I have a primary alcohol? I only want to take away one of these H's, right? So what does this look like? What if I only want to take one of these? And I want to get an aldehyde. We have a special reagent for that, and that's called PCC. I'm not going to ask you to know this, what the structure is. There it is. I'm not going to ask you to know why it does this. It does. So just know that that's like a tool in your toolbox that, it's the magic wand tool, if you want to call it that. Put it there. It's the magic wand. This makes primary alcohols into aldehydes. That's what you need to know.